Hi everyone, in this video we are going to explain stage in structural equation modeling. Before that, let me introduce ourselves. My name is Nabila and my group member is Farah, Harmila and Najiha. Moving on to the next slide, before we explain the stage in structural equation modeling, let I explain a little bit of structural equation modeling, what it is. Okay, a study by Ryan at 2012 is a multivariate statistical analysis technique which is used to analyze structural relationship between measure variable and related construct, and also known as SAM, and it can be taught as a combination techniques of factor analysis and multiple regression. Why SAM? This is because these methods are preferred by researchers since it could be estimates the multiple and interrelated dependence in a single analysis. In recent years, SAM has been extended in many ways. Moving on to the stage in structural equation modeling, the first one is assessing individual constructs. The second one is developing and assessing the measurable model validity. The stage 3 is specifying the structural model, and the fourth one is assessing structural model validity.
Stage 1.
Stage 1, assessing individual construct confirmatory factor analysis, is a special form of factor analysis is employed to test whether the measures of a construct are consistent with the researcher's understanding of the nature of that construct. There are three lists to do in this stage, which is to ascertain good measurement of the construct, in identify the type of construct, evaluation of the structure in relationship, in assessing the model validity of goodness of fit, and detecting the outlier. Now, apart from the observer variable, there are a few types of latent construct involved in SEM. Among the type of construct that researchers need to know are reflective construct, formative construct, and second-order construct. The reflective construct, as its name implies, the influence of this construct reflect on its response item. The single-headed arrow flow from the construct onto its item. Formative construct is a latent construct which is formed by a certain number of variables. The variables forming the formative construct are directly measured, thus no measurement error is required. The formative construct also become exogenous as well as endogenous construct in the structural model. The second order construct is a construct which consists of few first order construct. The first order construct is measuring using certain number of items in a questionnaire. Sometimes the first order construct is called the main construct, while the first order construct also one of the component of main constructs. Goodness of fit criteria, according to Hall in 1995-2010 and Homesmith in 2006, recommended to use at least one fitness index from each category of model fit. Absolute fit measures is to determine the degree to which proposed model predict the observed covariance metric. Example that usually used is chi-square root mean square of approximation, goodness of fit index, standard root mean square residual, and norm chi-square. Incremental fit measure to compare the proposed model to some baseline model, most often referred to as the null of independent model. Example that researchers usually use is adjusted goodness of fit, took Lewis index, norm fit index, and comparative index. According to Ho in 2006, parsimonious fit measure related goodness of fit of the proposed model to the number or estimate coefficient required to achieve the level of fit. Example method that usually used is chi-square degree of freedom, parsimonious norm fit index, and Akaye information criteria.
Detecting outliers. When to detect case-wise outliers, it will use the Mahalabi distance statistic. It computes the overall centroid and computes the distance of each observation from the centroid. The Mahalabi distance is known to follow a chi-square distribution, which the degree of freedom is the number of variables that are being tested. Usually, the even chi-square value at alpha 0.01 is taken as the threshold value. For example, there are two variables where the degree of freedom is equal to 2, the even chi-square value is equal to 13.186. If the highest value in the statistical test is 6.784, then there are no major outliers.
Stage 2. Stage 2 is developing and assessing the measurement model validity. While specifying the skill items, it is essential for us to specify the measurement model. In 2006, Hare et al. Has mentioned that each latent construct to be included in the model is identified and the measured indicator variables or items are assigned to latent constructs. The measurement models specify how the latent variables are measured. in terms of the observed variables. Figure 1 shows the example of measurement model with 4 variables. The first criteria for assessment is the goodness of fit GOF indices. Assessing the individual constructs, measurement model validity and structural model validity depends on a number of goodness of fit GOF indices. Goodness of fit measures the extent to which the actual or observed covariance input metric corresponds with or departs from that predicted from the proposed model. The GOF measures such as chi-square non-significant, goodness of fit indicator GFI, adjusted goodness of fit indicator AGFI, comparative fit index CFI, and for NFI is the norm fit index and Tucker-Lewis index TLI. They indicate a good fit to the model at about 0.9 or greater. The next criteria for assessment is the construct validity. The construct validity is the extent to which a set of measured items actually reflected the theoretical latent construct those items are designed to measure. Thus, it thus deals with the accuracy of measurement. Construct validity is made up of 4 important components, which they are convergent validity, discriminant validity, phase validity, and also nomological validity. The first one is the convergent validity. It is the items that are indicators of a specific construct should converge or share a high proportion of variance in common. The ways to estimate the relative amount of convergent validity are factor loading, variance extracted, and also construct reliability. The next one is the discriminant validity. Discriminant validity is the extent to which a construct is truly distinct from other constructs. As for the phase validity, it must be established prior to any theoretical testing when using confirmatory factor analysis. The last one is nomological validity. It is tested by examining whether the correlation among the constructs in a measurement theory makes sense or not. Stage 3. Stage 3 is when we specify the structural model. Once the measurement model is specified and also validated with CFA or confirmatory factor analysis, then the structural model is represented by specifying the set of relationships between constructs. The structural equation model is a comprehensive model that specifies the pattern of relationships among independent and also dependent variables, either observed or latent. Figure 2 shows an example of a structural model.
Stage 4. The assessing structural model validity focuses on 2 issues comprising: first, the overall and relative model fit. Second, the size, direction, and significance of the structural parameter estimate depicted with one hidden arrow on a path diagram. Accounting for error. SAM provides estimate for 2 types of error variance. First, error term. Error term represent measurement error associated with observed variable. For example, the degree to which the observed variable do not perfectly describe the latent construct of interest. Such measurement error terms represent cause of variance due to unmeasured variable as well as random measurement error. Second, residual term. Residual term represent the error in the prediction of endogenous factor from exogenous factor, that is to say, how much variance in the associated endogenous variable was not accounted for by influences in the model. So, that's all from us. Thank you.
Have a good day.